Welcome back. Today we're learning about some practical ways to use objects. Last time we looked at how to create basic objects, which meant setting properties and methods. Now we're going to use those objects in an object-oriented program. Using object-oriented programming lets us do complex actions in a way that's easy to understand. Let's start with the dog class we created last time. Let's say I want to take this program further. I want to create an animal shelter where you can adopt dogs and drop off any dogs you find on the street. So what would be an easy way of doing that? One good answer is to use another object. In programming, we create objects that have more objects inside of them. One can hold and manage many others. An animal shelter object makes perfect sense to hold dogs. Okay, underneath the dog class, I'll start writing a new class called animal shelter. The only property it will have will be a list of dogs. I can define that property in the initialize method. I set it to be an empty list, so the shelter will start out with no dogs. Let's create a method that adds a dog to the list. This will take in a dog object and append it to the dogs property. If you want to add a dog to the shelter, you'll first have to create the dog object separately, with a name, age, and color. Let's keep that in mind for later. We'll also need a method of adopting dogs. This one is a little more tricky. We could give a dog object and then .remove the item from the list. But how would we get that object in the first place? We'd have to write another method that gets one dog out of the list, and then pass that value into the adopt method. Let's just simplify this into one step. Instead of an object, let's supply a name, and then remove the dog with that name. To do that, we'll need a for loop over every dog in the list. With an if statement, we can check if the name matches. If it does match, we remove the dog, then print a thank you, and lastly return so the method stops. If the loop somehow came to an end, that means that the return never ran, and no dog in the list had that name. We can print, could not find a dog with that name. For the last method in this animal shelter class, let's call the introduce command on every dog so people can come in, meet them, and adopt them. This one is easy. Print how many dogs there are with the length command, and then use a for loop to call the method on every dog. Last thing, I'll add docstrings to every method to describe what they do and what data they require. You can also add a docstring to classes themselves, so when you hover over the object instantiation, it shows you what the class is used for. Just put the docstring right at the beginning of the class block. For this class, I can say something as simple as holds found dogs for adoption. Cool! Now we have the tools we need to create a really great program. First, let's test out what we have written before moving on. I'll create an animal shelter object, then create 3 dog objects. I'll add these dogs to the shelter with the add dog command. We should be able to see them by introducing all of them. Then let's remove 2 of them, given their names. And why don't we see if it does the correct thing when we give a name that doesn't exist in the shelter? We can check if they were successfully adopted if they don't show up in the introduction method. So let's call that again. If I run this and check the output, everything looks like it works so far. It printed out all 3 dogs, adopted Luna and Bean, couldn't find Code Dog, and then introduced Ocean. Nice. Now we can start making the main logic of the program. When making a big program, I prefer to store my classes in a separate module. I'll move them to a file called dogs. You don't have to do this in your own programs. I just like to break up big parts of my code into different files so I can reuse them easily. In the main file, I can then import them to use them. Now we can write program code using the classes we just defined. First, I'll make an animal shelter object stored in the variable pound. Then I'll make a menu for the users to pick what to do. We learned how to do this in Unit 3. The 4 options in the program will be to view the dogs, adopt one, drop one off, and to quit. I'll take input and then use another if statement to run the right code. If the user chooses to view all dogs, that's easy. Just call pound.introduceAllDogs. If they choose to adopt, we need to ask for the name and then call pound.adoptDog given the name. Makes perfect sense. To drop off a dog, we first need to create a dog object, because that's what the method takes in, remember? To do that, I'll ask for a name, age, and color, and then create a new dog. Finally, the add_dog command, given the dog we just created. And believe it or not, we just created an entire animal shelter program. Using objects, we could fit the entire program in less than 40 lines. Imagine how much effort that would take if we didn't use objects. Let's test it out. Obviously, if I choose to meet all of the dogs, there should be 0 because we just started the program. So let's add one. I'll name it Molly. Now when we go to view all of them, we can see her here. Let's add a second dog. I'll call it Spot. Again, it shows up in the list like we expect. Now let's get Molly out of there. If I adopt, it asks for the name and prints out the thank you. Again, Molly is gone from the shelter and therefore gone from the list. Cool. Hopefully you can start to see the value of objects. Once you get the hang of them, they can be exactly what you need to make awesome programs. This example was basic and only had 3 functions. Can you think of how you could add an option to teach dog tricks? How about adding cats to the animal shelter? It's all possible with objects. In this program alone, we used every big concept we've learned so far. Commands, operators, conditionals, lists, loops, functions, and wrapped it all together with objects. In the next unit, we're going to dive into graphics and start making programs with shapes, colors, animations, and more. Stick around. CodeDog out.